But this seductive new theory is also controversial. Strings, if they exist, are so small, there's little hope of ever seeing one.
String theory and string theorists do have a real problem. How do you actually test string theory? If you can't test it in the way that we test normal theories, it's not science, it's philosophy. And that's a real problem.
If string theory fails to provide a testable prediction, then nobody should believe it. On the other hand, there's a kind of elegance to these things. And given the history of how theoretical physics has evolved thus far, it is totally conceivable that some, if not all, of these ideas will turn out to be correct.
I think 100 years from now, this particular period when most of the brightest young theoretical physicists worked on string theory will be remembered as a heroic age when theorists tried and succeeded to develop a unified theory of all the phenomena of nature. On the other hand, it may be remembered as a tragic failure. My guess is that it'll be something like the former rather than the latter. But ask me 100 years from now, then I can tell you.
Our understanding of the universe has come an enormously long way during the last 3 centuries. Just consider this. Isaac Newton, who's perhaps the greatest scientist of all time, once said, "I have been like a boy, playing on the seashore, diverting myself and now and then finding a smoother pebble or prettier shell than usual, while the great ocean of truth lay before me, all undiscovered." And yet, 250 years later, Albert Einstein, who was Newton's true successor, was able to seriously suggest that this vast ocean, all the laws of nature, might be reduced to a few fundamental ideas expressed by a handful of mathematical symbols.
And today, a half-century after Einstein's death, we may at last be on the verge of fulfilling his dream of unification with string theory. But where did this daring and strange new theory come from? How does string theory achieve the ultimate unification of the laws of the large and the laws of the small? And how will we know if it's right or wrong?
No experiment can ever check up what's going on at the distances that are being studied. The theory is permanently safe. Is that a theory of physics or a philosophy?
It isn't written in the stars that we're going to succeed, but in the end, we hope we will have a single theory that governs everything.